Hi guys, this is the beginning of chapter 7. So you'll notice in chapter 7 we are talking about real numbers, and then we're going to be talking about something called the Pythagorean theorem. On the next page you are going to need to know perfect squares. So I have listed them over here. So you can see that there are several. So basically what this little 2 means is the second power. So that means 1 times 1 is 1. 2 squared, or 2 times 2 is 4. 3 squared, or 3 times 3 is 9. 4 squared, or 4 times 4 is 16. So these numbers over here are all of the perfect squares. And I would suggest you pause this, write all of those down. I bet you that no matter what 8th grade math teacher you have, they are going to require that you memorize these. They'll let you know if there's something different, but probably up through 15 squared, which means 15 times 15, which is 225. So probably going to need to have those memorized. So do that. Take a couple of seconds, write all of those down, and start committing those to memory. I'm going to go ahead and go to the next page and kind of get going on this. So 7.1, finding square roots. A square root, like it says here, of a number is a number that when multiplied by itself, it equals the given number. So for instance, the square root of, whoopsie, sorry about that. For instance, the square root of 9 would be 3 because 3 times 3 gives you 9. So every positive number has a positive and a negative square root. We'll get to that again here in a second. A perfect square is what I told you about on that first page. Those are all of the numbers that have integers as square roots. So like the square root of 9 is 3. The square root of 4 is 2. Those answers are integer square roots. This is the symbol for square root. Kind of reminds me of your old school division house. It is called a radical sign. It's radical, dude. It is called a radical sign, and it is used to represent a square root. And the number under the radical sign is called the radicand. Alrighty, so here in example 1, it says finding square roots of a perfect square. Find the 2 square roots. So when we take the square root of 49, it is 7 because 7 times 7 gives you 49. But there is also the negative square root of that because negative 7 times itself would also give you 49. So there are technically always 2 square roots of any positive number. Okay, and here's how we are usually indicated. Right here, typically, square root of 16, we just want you to give us just the positive typical answer. If we just want the negative answer, we'll put a negative outside of the radical. And if we want both, we'll make sure and put the plus and minus to remind you that the square root of 16 is both positive 4 and negative 4. And you can just use that symbol as you'll see down here. So on finding these square roots, the square root of 25, since it doesn't have anything out front, they're just wanting the positive square root, which is 5. This one, oh no, freak out, there's a fraction. Well, this can be rewritten as the square root of 9 over the square root of 16. Okay, and don't forget your little negative out here. So the negative, what is the square root of 9 is 3. What is the square root of 16? That is a 4. So don't stress out when there is a fraction, and we'll talk about a different type here in a little while. But notice both of these are perfect squares. Square root of 9 is 3. Square root of 16 is 4. Make sure and carry your negative all the way over. This one, again, you're like, freak out, oh no, there's a decimal. Well, if you look at that list that we made on the first page, the square root of 225 without the decimal is both positive and negative 15. With the decimal, we just need to put the decimal in there. Or, rest assured, we will not make you memorize decimal square roots, so we will teach you how to do that in your calculator. So here are 3 on your owns. it says find the two square roots. So make sure you pay attention to those directions there and pay attention to whether your teacher told you to do the on your own or not. So you could probably have those, you probably do have those three finished by now. All right, and then on this one, find the square roots. So this has a negative out in front. So we are going to, you know what? I think those are part of on your own. Even though they're labeled ABC and ABC again, I'm going to go with those are on your own because we've already done ones like that. Go to the next page, please. All right, on this next page, give us a little note. Squaring a positive number and finding the square root are inverse operations. Inverse operations mean opposites, kind of like we've been using to solve equations. The opposite of adding is subtracting, or the opposite of multiplying is dividing. So inverse operations are opposites. So you can use this relationship to evaluate expressions and solve equations involving squares. I will point that out down here in one of these examples. Evaluating. Evaluating just means work it. Work it as much as you can. So when we do this, we have to always consider our good old Aunt Sally. So please excuse my dear Aunt Sally. Write this on your paper, please. The P we know is for parentheses. The E you probably have known is for exponents, but is also for roots. We've been talking about square roots here. So E is for both exponents and roots. P parentheses, E is for exponents and roots, multiplying and dividing, and then adding and subtracting. So when you are working these, you have to consider the order of operations. So on this one, the 5 squished against the square root of 36 implies multiplication. And then, of course, plus 7. So do we multiply, square root, or add 7 first? According to our order of operations, we have to do exponents and roots first. 5 is going to drop down. We said that implies multiplication. The square root of 36 is 6, and drop down your plus 7. Multiply would come next, so we have 30 plus 7, and finally our answer is 37. We have evaluated that expression. Okay, and I know you guys like to freak out when you see fractions. Don't freak out. All right, 1/4 is going to drop down because we, again, have to do our exponents and roots first. This one, when you look inside, the square root of 18 or 2, neither one are those perfect squares we were talking about. So you can do what's inside of here. We're going to keep the square root for now. What is 18 divided by 2? It is 9. Now, we can work the square root of 9 and get the 3. We still have this 1/4 out front. And then some of you are going to reach for your calculators. You don't need that. 3 plus 1/4 is simply just 3 and 1/4. So when you can divide what's inside of the radical, go ahead and do that first. Okay, this one refers back up to here. So I'm going to work this out 2 different ways. So if I just start using my order of operations, I say, okay, I'm supposed to work inside parentheses, and then inside parentheses, the only thing to do is the square root of 81, which is 9. That's inside parentheses. I still have squared and minus 5. Well, then I have to do exponents. So 9 squared is 81 minus 5. Right now you're like, what? That was 81 minus 5. Did I really have to do all of those steps? No, you did not. So squared and square root are inverse operations. So they technically cancel each other out. Switch colors here. So square root, squared. Inverse operations, making this problem simply 81 minus 5, which is 76, which is the same thing you got over here. So no big deal if you don't recognize that these are inverses and cancel them out. It'll just take you more steps to get your answer. All right, moving on. Little area, little review of the formula that we need for the area of a circle. And that formula, you should know this, but it is A equals pi r squared. The area of a crop circle, that's how I knew we needed this formula, is this in square feet. What is the radius? Radius is going to be the R of the crop circle. Use 3.14 for pi. So area is 45,216. Got that from right here in the problem. So I'm plugging that in for area. The area is, so put that number in for A. Pi is 3.14, and we're finding R. So we don't know that, we'll just keep the R. To solve equations, to get the R isolated when it's being multiplied by something, we are going to divide both sides by 3.14. Of course, you would use a calculator on this side. When you divide here, you get 14,400. Pi's cancel out over here, equals R squared. Okay, and we talked about inverse operations at the top. This is not asking me what's the radius squared. It just wants the radius. So how do I unsquare something? You are going to square root. So you're going to square root this side, put that in your calculator. Square rooting something that is squared cancels, giving us just the R on this side. And then using your calculator, you get 120. I'm going to go back and figure out 120 equals my radius. 120 what? Feet. So when you have R squared, to unsquare, let's write that out here. To unsquare, we square root. And that is it. So you will work these on your own or listen to what your teacher said as far as working these. Use your order of operations. Oh, hey, look, we can divide inside of that one. Decimal, no big deal. See what you get here. Do some adding. Hey, here's a square root and a squared. Those are those inverse operations we talked about. So these should go pretty quickly. This problem is going to be like this problem up here, except for you're going to be putting in 2,826 feet for the area like it says. And that is it for today. Thanks, guys.